We'll get started with the advanced Git tutorial. So a few things that we're assuming that you already know is that you're familiar with some basic Git. So you know how to stage changes and commit them, and then also push and pull to and from a remote repository, and then also working with branches. So you know how to create a branch and switch between branches. And this tutorial is not exhaustive, so there's going to be a lot of material that is not necessarily covered today. And the purpose of this tutorial is more just to cover advanced topics that you're going to more commonly come across when you run into issues. But of course, there's a lot more that you can learn about Git. So there's some resources at the end of this slide set that will point you towards if you're curious about learning more on advanced Git topics. But we'll start with some basic operations. So I found this nice chart online that kind of summarizes some of the basic Git commands and how it interfaces with some of the Git internals. So there's typically 5 things that you worry about. The first thing on the left is called the stash. So the stash is really just a stack that stores all like a bunch of, I guess, patches that you can apply onto your files. If you've ever tried to switch between branches or pull from main, sometimes Git might ask you to stash or commit your changes. So what stashing actually does is that instead of committing your changes, it'll actually take that diff and store it in some stack somewhere that you can pop off later when you want to reapply those changes. So maybe an example of this is, maybe I'll add I don't know, an extra line here. Here is an extra line. And if I do git status here, it's going to show up. Oh wait, no, it's not going to show up because I didn't save the file. There we go. And if we look at the current stash right now, you can look at the stash, just git stash show. It's going to show up as empty because right now it's empty. But you can to stash your changes, all you have to do is do git stash, and it will save all your changes on the stack. And if you do git stash show, it'll actually show that you've changed one line in cellbot.txt. And if you want to reapply those changes, you could do git stash pop, and it'll reapply those changes back onto your workspace. So the next thing on this list is the workspace. So the workspace is essentially it's essentially your current working changes that you've not yet staged. And the next thing on the list is the index. So the index is essentially the next proposed commit. So whenever you do git add, it's going to take your changes in the workspace and then add it to the index, and it's essentially the proposed next commit. So if we do git status here, cellbot.txt is going to show up in red, meaning that our workspace is modified. But our index is not yet updated. So we actually have to add cellbot.txt. And now cellbot.txt shows up in green, which means it's been added to the index, meaning that this line that we added here is the proposed next commit. And then when you actually do git commit, it's going to take whatever's in the index and add that to your, I guess, the copy of your local repository. So when you actually do git commit, -m, and when you actually commit your changes, if you do git status again, your working tree is gonna show up as clean, but then if you look in your git log, it's actually gonna show up as a new commit. And then of course there's the remote repository that you interface with, that you actually push and pull from, which is different than what you have which may be different than what you have on your local machine. So I'm going to clear this. Just a few tips on using some of these basic operations. I recommend using git status often because it often helps you determine the current state of your repository. And when you're using git add, What I see a lot of people do is they'll do git add dot, which what it means add everything in the current directory, but sometimes you might not always want to do that because there might be some files that you don't necessarily want to add, or that you might not want Git to track. And sometimes you might only want to add the files that you're already tracking. So an example of this is maybe I'll add an extra line here, but then maybe I'll also create another file. If I do git status, Git's going to say that I have sailbot.txt is modified, but I also have an untracked file called new file. But maybe I don't want to track new file. So what git add dot will do, I'm not going to execute it, but it'll actually take both of these files and add it to your index. But if you say only want to add sailbot.txt or only your tracked files, you could do git add -u. And if you do that, it'll actually only add sailbot.txt, but then you see that new file is untouched. So I recommend using git add -u typically over git add dot unless you really want to add everything, which sometimes you do, but.
Also, like one more best practice for this is you don't need any untracked files if you add everything to your git ignore. Right?
Yeah. Yeah. So for those of you on Zoom, Patrick also said that you can also add files that you don't want to be tracked to your git ignore, and Git will just not even consider it at all. So that's also another alternative. And then git commit, you can both add and commit tracked files in the same command using git commit -a if you would like. But there's also another, I'm actually gonna undo this change here just quickly. So I'm gonna, yeah. So the last thing on the list is amending commits. So if you want to make a change to a commit that you've made changes to most recently, say if I look at the logs and I say, hey, actually, I want to change this commit message and I want to amend this commit, you can actually change what the content in the commit using git commit -amend, and then you'll be given the option to actually change the commit message. Maybe I'll just add a number here. And then if you look at the git log again, we see that the message has been modified. And another use of amending is you can also add some more changes to your commit. And then when you amend that commit, it'll take what's in the index and add it on to what was already inside of the commit. But it's not recommended that you amend commits that have already been pushed because it'll actually change the commit hash and it will cause issues if you try to push. And if other people have already pulled that commit, and if you like say force pushed it, for example, that's going to cause conflicts in other people's local copies. So I only recommend amending commits you haven't pushed yet. Then another thing is you've already seen it a couple times, but if you want to view your commit history, you just use the git log command, and you can scroll through your previous commits that have already been made in the past. It's pretty simple. There's a few notes here on undoing changes. So there are a few differences. So if you want to undo changes in your working directory, say if I add a change here, if I have saved changes, if I do git status, and if I'm not happy with the changes that I made and I want to restore it back to what was on the previous commit, you just use the git restore command and it will actually undo the changes in your working directory. Sailbot.txt, and if you see the file got updated back to what was in the previous commit, and if you do git status again, sailbot.txt doesn't show up anymore. You could do something similar if you stage changes. You can do git restore --stage, which will actually undo, it will unstage your files that have already been added to the index. And then there's some other commands that are covered here, git revert, git reset, and git rebase. Git reset and git rebase will be covered a little bit more in detail later in this tutorial, but I can actually cover git revert right now. But git revert essentially, it makes another commit that undoes your previous commit. So what it'll actually do is it'll look at your previous commit and it will apply a diff that is exactly the opposite of what that commit was, and then that essentially undoes your change. And this is actually a safe way of undoing changes in Git. Git reset and git rebase are a little more destructive ways of doing the same thing, but they each have their own benefits. We'll kind of cover in a bit. Okay, that was the easy stuff. So next thing that we're going to be covering is branch pointers and the head pointer. So what are these things? So you could think of a branch pointer as essentially the pointer that points to the latest commit of a particular branch. So in the example below, C3 is the latest commit in main, and main will point to C3. The head pointer is a reference to your current commit, and usually that means it will point to a branch pointer which points to its latest commit, but that doesn't always have to be the case. You can actually move the head to a different commit, and it doesn't necessarily have to point to a branch pointer, and that's referred to as detached head mode. And one more thing is whenever you make a commit, it will actually advance both head and your branch pointer. So for example, if I made like another commit C4, it will move both head and main to C4. So why is head important? Well, if you've ever switched branches, what switching branches is really doing is that it's taking your head pointer and it's moving to the branch pointer that's associated with the branch that you're switching to. So for example, here, head used to point to main, but if we say we want to switch to the feature branch, it will move head to the branch pointer for the feature branch. So we can actually kind of see this in action if we look at the Git log. The branch I'm currently on right now is called Sailbot Demo. And you'll see that the head is currently pointing to the Sailbot Demo branch pointer, which points to this commit here, our latest commit. But if we scroll down a little bit, we also see that there is a branch pointer for main. But this branch branched off of main, and we added a little bit more commits. So that's why head is pointing to the Sailbot Demo branch pointer, but it's not pointing to main. But of course, if we want to say switch back to main, we go back to git log, now head points back to main. So hopefully that it's a little more clear on what's happening here. Oh, another tip too, if you want to switch back to the branch that you were on previously, you can just do git switch dash and it'll switch back to the branch you're on before. I use that all the time. Same thing with cd. If you change directories in the command line, cd dash, it'll go back to the previous one. That brings me to git switch versus git checkout. So what's git switch? Well, it's really just a special version of git checkout. Git switch is specifically for switching between branch pointers, but you can use git checkout for the same purpose, but git checkout more generally can change your head to any commit that you choose. And if you change your head to any commit that is not pointed to by a branch pointer, you are in something called detached head mode. So whenever you see, like, if you switch to a commit, you see it say detached head mode, that's what it really means. And if we actually, maybe I might, so in this commit here, we actually added this extra line here. So maybe I might want to switch to this commit here. So maybe I'll copy the commit hash and I'll say I want to check out to this commit here, and it's going to say, oh, you're in detached head mode. Where does it say that? Does it really say that? Head is now blah blah blah. Yeah, here it is. You're in detached head state, And if you look at the file above, it actually reverted back to the commit that was made before. But if we look at git log, we see that head is pointing to the commit that we switched to. And we can always just switch back to the branch that we were on before by just going to, we can either use git switch or git checkout, doesn't matter. But I'll use git checkout here. You can git checkout back to, I think it was sailbot demo. And I'm saying I want to move head back to the sailbot demo pointer. And if we go back to git log, it's pointing, and head is pointing back to the sailbot branch pointer. Okay, so that's enough about head and branch pointers and understanding what head. Sorry, go ahead. Origin in main. I don't cover remote references in this. Yeah. It's like on a list later. Okay. So the next thing that we're going to be covering is using git reset and understanding git reset. It stems off from understanding what head is. So understanding what head is will help us with the rest of the content in this tutorial actually. So it's important that we understand what head is in order for us to continue. So explaining what git reset is in words is kind of hard. So it's better to explain it with a more of a illustration / demo. But in order to do that, first we need to understand the 3 main trees in Git. We already actually covered this earlier, but we'll reiterate here. So the head is, again, the pointer to your current commit. But if we go back to a few slides ago, remember how we had local repository here? It's basically, local repository and head are basically equivalent here. If you remember what that is, head is basically the same thing. The index is your next proposed commit, and then your working directory is your current working changes. And there are 3 types of resets: the soft reset, the mixed reset, and the hard reset. And they each modify these 3 trees in sequence. So I'm actually going to start off with illustrating an example here. So suppose that we're at an arbitrary commit, which has a file with version 3 of a file. So there are actually 3 commits that were made on this file before. So this is version 3. And right now, the head is pointing to the commit, and the index and the working directory look exactly the same. And if we actually do, first of all, if we do git status, that's exactly where we are right now. We have a clean working tree and nothing in our index. So this is exactly where we're at the moment. So with that in mind, let's start by understanding what the soft reset is. So what the soft reset does is, all it does is it takes your head pointer and it rewinds it by 1 commit. But it still maintains the index and the working directory to be the same as the commit that you rewinded from. So an example of this is, if we look at git log, remember that this commit that we're at right now added this extra line here, and the commit before here just had millinode timelines are due at May 1st, right? So if we do a soft reset, so head tilde just means rewind by 1 commit. If we go back to git log, our head is pointing to the previous commit, but notice how the file looks the same. And if we do git stat, that's not what I wanted. If we do git status, notice how sailbot.txt, the index is the same, and so is the working directory. So all the soft reset did is it rewinded head, but didn't change the index or the working directory. So that's it. And then the next type of reset is called the mixed reset. And what the mixed reset does is it goes 1 step further. It will rewind the head by 1 commit, but it'll also make your index look like head. So what that looks like is I'm actually gonna recommit this again because I want to go back to the state that we were in before. I'm just redoing the commit here. And if we do just git reset head tilde, which is the mixed reset, and stage changes, yep, it's going to rewind back to the commit before, right? But if we do git status, notice how cell.txt isn't in green anymore, it's in red, indicating that the working directory has changed, but the index has not yet been updated. So that's what the mixed reset is. And the last one, which is the most fun, and I use the most often, is the hard reset. And what the hard reset does is it will also make your working directory look like your index. But what would that do? Anyone have any guesses what that would do? What's like the equivalent? It's like you're dropping the commit entirely. So I'm actually gonna, again, for the sake of the demo, I'm gonna recommit this again. I'm gonna go back to the previous state. So right now we have our new commit here, which is the state that we're currently in. But if I do a hard reset, git reset -- hard head tilde, it's gonna rewind the head, make our index look like head, but also make our working directory look like head. And notice how before, every time, like when we did a soft reset and a mixed reset, this file still had this extra line at the bottom, but notice when we do this hard reset, it's going to drop it entirely. Should have dropped it entirely. Okay, maybe it didn't drop it entirely. Why didn't it do that? Oh, maybe because I didn't save the file. Okay, well, it dropped it entirely. I guess it was just something to do with me not saving the file, but basically it dropped the commit entirely. So if you want to drop a local commit, you can do a hard reset. But you want to be careful with doing this because you might potentially lose some work if you do a hard reset. Because if you have some changes in your working directory, but you haven't committed it before and you do a hard reset, you're actually going to lose some of that stuff. And so the rule of thumb is you always want to commit your work as often as possible. So if you run into accidents like this, if you accidentally hard reset, you can still recover your work.
How would you reset more than one commit?
How would I reset more than one commit? Good question. So I'm not going to execute this because I don't want this to run, but say if I wanted, so the command that I did just now, git reset -- hard head tilde, that will go back by one commit. But if I want to go back by 2 commits, you can add the number of commits you want to go back by. So this will drop 2 commits instead of just 1. I've personally never did a soft reset or a mixed reset by more than 1 commit. I don't know how that would work actually, so maybe you can try that out on your own time. But I've definitely did a hard reset over multiple commits because I just wanted to drop a bunch because I didn't, I made some mistakes and I didn't want to see those commits anymore, so I just dropped a bunch of them. Yeah, good question though. One more rule of thumb: if you push the commit that if you want to undo a commit, but you've already pushed it, don't do a hard reset and then force push, because what that will do is will actually rewrite your history. And if there are other people working on your branch, again, what's going to happen is your history, you're going to force push a different history than what they have. And if they try and get pull, Git's not going to know what to do because your history now looks different. And in that case, I just strongly recommend to use git revert. Unless you know for sure you're working on a branch all by yourself, then maybe you can drop some stuff and do some force pushing if you want to, but you should only really do that if you know what you're doing, and only do it on your own private branches. Don't do it on main or any branch you're actively collaborating with, because there's gonna be some very unhappy people if you do that. Just say that. Okay, and then one more thing is I mentioned earlier how there's a possibility that you can lose work if you do a hard reset by accident, but all is not lost if you commit your work. So yeah, or if you will commit, well actually the bare minimum if you want to recover your work is just to commit, but of course pushing you'll have the extra safety factor of it being on the remote repository. So actually, I can do that right now. So actually, these commits are not actually pushed to remote. So what I'm going to do is I'm going to push these commits to, oh yeah, see, like you can tell I haven't pushed it yet because it wants me to set up stream. So I'm going to push these, oh, sorry, I'm just going to, oops. Sorry, just setting my SSH key so I don't have to deal with this. Okay. So I push my changes and say like, you know, maybe I accidentally hard reset a bunch of commits. Maybe if I accidentally hard reset by 2 commits or something. You know, and then yeah, these are, well, oops. Yes, sorry, my Git's being a little weird. Buddy. Okay, well, these 2 lines actually go away. It's just, it's being difficult with me today. But anyways, those 2 lines, by rewinding by 2 commits, would have dropped those 2 lines. So, you know, oops, I hard reset and I lost my work. But if you've already pushed your stuff, you can just do a git pull and it will restore your work just fine. And then, you know, you'll be good to go. And your stuff is back to where it should be. But let's say I'm going to add a commit and maybe say like, I want to recover this. And I'll save this, oops. I'll save this file. Well, first of all, I'll save the file. Okay, so I made a new commit, I added that extra line, and I have this here, but I haven't pushed it yet. And let's say I do a hard reset. Oh, it's hard, yeah, sorry, git reset -- hard. And now I've lost that line. Oops, oh. So I've lost that line, and you know, you can't do a git pull, right? Because if you try that, then you know that's not going to recover your work. It's going to say it's up to date, and that's not going to work for you. So, if you lost your local work, what do you do? Well, that's where Git Ref Log comes to the rescue. So if you've committed your changes, what Git does for you, which is really nice, is it will keep track of your local state through something called a reference log. And you can actually take a look at this reference log through the command git ref log, and it will show you all the things that you've done so far. Oops. It'll show you all the things that we've done so far with Git. So for example, look, like my latest command was performing this hard reset where I actually dropped the commit by accident. But if I want to recover that commit that I just lost, I need to revert the local state back to before the hard reset occurred. And you can do this by taking the reference that happened just before the hard reset, and then you can use that reference from the ref log to essentially revert state back. So in this case, that reference just before the hard reset is head at 1. So you can actually, in the command to do this, you could just do git reset head at and then 1, the reference. And what this will do is it will go back to what happened before. Excuse me. It'll go back to what happened before the hard reset. And well, I guess actually I went back by 2 references here, let's see. Yeah, I thought it was at 0. I thought it was, anyways, let's see. I'm gonna make this full screen because it's easier to look at that way. So I hard reset here, then I made a commit here. Yeah, should have went back to here actually. Oh, whoops. Okay. Yeah, okay. So basically what happened was it actually deleted this line when we did the hard reset. So it actually just was able to recover that work. And if we go back to git log, it actually recovered that commit that we dropped by accident. So that's how you can recover your work locally if you haven't pushed it yet. Very useful. And yeah, it's very stress inducing when that happens for the first time. You're like, oh, I know how to use git reset, and then you drop stuff by accident. Yeah, I had a meme here. I'll play it. Maybe it'll load. It's like so that will be you if you don't commit your changes and you did a hard reset, because yeah. Yeah, so just commit your changes because you're not going to be very happy about losing your work forever. And then just a note on stashing. So remember before how we say if we want to switch to another branch, we make like a change here. Blah. I don't know. That's not blah. If I try to switch to main, it's going to ask me to stash or commit my changes. So usually you can stash your kit. You can stash your commit, or sorry, stash your changes, and then you can switch to another branch, and then you can always pop back those changes after. But the disadvantage of using git stash is you have to like remember at the top of the stack, you have to remember where that stash came from, because if you stashed multiple times and you switch between branches, the stash is shared like it's shared across actually it's shared within the same repository, but it's shared across branches. So you might have stashes that you stashed from different branches, and you might eventually forget where that diff came from. So that's the disadvantage of using stash. But what you can do instead is you could perform a temporary commit, and then and you can switch away from that branch, do whatever you want. But then when you come back to that branch, you can do a mixed reset, and it will preserve those changes in your working directory, but without having actually, it'll basically undo that temporary commit and remove it from the index, and it'll still be in your working directory. And the advantage of doing that is, well, you don't have to remember what diff came from where, because it's been committed. You're not pushing it onto a stack or anything like that. Oh dear. And then there's merging and rebasing. I'm going really overtime here. Yeah, I don't know. Yeah, it's the last section. Yeah, I'll go very quick. So next section is merging and rebasing. So if you've ever been on GitHub and you opened a PR and it said squash and merge, if you click squash and merge, there's actually 3 different types of merges you can do. The first is a merge commit. What it'll do is it will create a new commit called the merge commit on main, and it will essentially join both your feature branch and main together for that single commit. And it's pretty simple, but you could get pretty messy Git histories pretty quickly if you have a lot of these merge commits. So the other two alternatives are kind of methods to avoid these messy histories. The next is the rebase. So the rebase, all the rebase does is it'll take your future commits and move it on top of main. And then what squash will do is it will take all your commits, squash it into one, and then it'll just take that single commit and put that onto main. But the golden rule of rebasing is you should only rebase on your own private branches and never on a public branch. And the reason for this is whenever you rebase, it actually creates new commits. So it'll actually copy the diff from your commit and it'll create a new commit. And if you run into this scenario where, say, you rebase main on top of your feature branch, it'll actually change the history such that it'll actually create new commits here, as you can see here. And if everyone else's history looks like this, and if they try to do a git pull or merge your pull request with their stuff, their histories are going to look different. So you're going to run into issues there. So don't rebase on public branches, only on your own. And then there's interactive rebasing. So interactive rebasing really is just a method of performing like some sort of branch cleanup. And again, you should only really do interactive rebasing on your own branches, not on public branches. But to summarize, what an interactive rebase will do is it will rewind your head by however many commits you tell it to rewind by. Git will ask what command you want to execute at each commit, so you can choose to keep the same commit or edit it or change its message or drop it entirely, whatever you want to do. And then depending on the command, it'll execute it depending on the specification and potentially create a new commit. If it's modifying the commit in any way, it'll actually generate a new commit with a new hash. And then head will advance to the next commit, and it will repeat these operations until it's gotten back to the end. So kind of an illustration on how this works is, say you have this example history here, and if you want to do a rebase by 4 commits, the first thing it'll do is head will rewind by 3 commits, and say we want to edit C2. You specify that C2 has to be edited to have a new commit message, so that'll happen, and it'll create a new commit C2 star. And maybe we want to drop commit 3. Maybe we don't want the changes to commit 3 anymore. So it'll drop commit 3. Maybe we want to keep commit 4 the same. And then maybe we want to edit the stuff in commit 5. And it'll create a new commit C5 star. And then that's it. I guess yeah. If you're doing an interactive rebase on commits that you've already pushed, you can still update the history by force pushing, and you can do that, but it's, again, only on your own private branches. Yeah, and if you force push it, it is a destructive operation, so you want to make sure you really know what you're doing before you actually do the rebase. I guess maybe I'll take a moment to maybe just do an example interactive rebase really quickly. So maybe I'll go back by 4 commits here. Oh, yeah, you have to make sure all your stuff is clean. And then it's going to ask me what commands I want to do, or what commands I want to execute on each commit. So obviously I want to, maybe I want to keep the first line, so I'll keep the first line. Maybe I want to edit commit 2, maybe I want to change the Y's words here, so maybe I'll change it to edit. And then maybe I want to squash the previous commit, this commit into the previous commit, right? Maybe combine them together. And then I want to, maybe I want to drop commit the last commit because I don't want it anymore. So once you define what commands you want to do, you just save and close this file. and then the interactive rebase will start. So right now I want to edit the wise words, so I can always, you know, sometimes you just need to take a step back maybe. I'll save that. And then once I'm ready, once I'm satisfied with my changes, I'll add -u and then git commit. I'll amend this commit. Remember, amending will change the commit, right? Add some wise words, and then I'll continue the rebase. Sometimes I need to take a step back, and then I get a merge conflict because I have some stuff here. I will take the maybe I will take both. I'll accept both changes, but then I'll just get rid of that because I don't want it anymore. Git commit -amend. Git rebase -- continue, and that's it. And then if we look at the git log now, we have some wise words. We actually dropped that last commit. Remember how we had a fourth line here? We actually dropped that last commit as we wanted to in the rebase. And then it actually changed the commits here. So if I actually try to do a git push here, I think it's going to complain saying that the histories were diverged. So if I want to actually get the changes because I actually rebased some of the commits I already pushed, so I would have to force push to this branch if I want to actually update remote. So I can do git push. So I would recommend using force with least, because what that will do is it will check that there were no new commits that were pushed to the remote branch before it'll actually do the force push. So it'll do that, and then that's it. We've updated history. But yeah, at the end of the day, when you're rebasing, always remember the golden rule: don't do it on a public branch, do it on your own. Stay in your own lane, as they say. And then there's some other topics that we didn't cover, like Git configuration, aliasing, working with remote references, and other things. And if you want to check out some more advanced Git topics, you want to check out the Git SCM, that's the official Git documentation. Okay, I know that was a lot, but this was recorded, so hopefully this would be useful for you guys down the road.